Chapter 2 of our textbook is titled Atoms, Molecules, and Ions. And we're going to start in section 1 by discussing atomic structure. So macroscopically, matter is classified in 3 ways. And we talked about this in chapter 1. We have elements, we have compounds, and we have mixtures. It's macroscopic. This is visible to our eyes, and we can discuss the properties just as we did with chapter 1. But now, what happens when we look under a very, very fancy microscope to see how to characterize matter? So microscopically, we can say that matter is discrete. And by saying that, we can say that it is made up of atoms. All atoms of a given element are identical in chemical properties. Another way of saying this is that atoms of different elements have different chemical properties. As chemists, we are very, very interested in the chemical and physical properties of matter. So we need to look at this atomic structure and look at these atoms and see how they behave in order to predict the properties and try to interpret how they fit into our everyday lives. One thing about atoms is that atoms are very small. For example, a cesium atom has a mass of 2.21 times 10 to the minus 22nd grams. So we're dealing with very, very small particles here, and most of the balances that we use are not going to be able to detect atoms down to this scale. We also know that every atom is made up of subatomic particles. These 3 subatomic particles are the proton, which we'll abbreviate with a lowercase p with a plus subscript. The plus subscript is there because it has a +1 charge. In terms of its mass, it is 1.0073 atomic mass units. A neutron is abbreviated with a lowercase n with a 0 subscript. It is neutral, so it does not have a charge. It has a mass of 1.0087 atomic mass units. And the third subatomic particle is the electron. We will abbreviate the electron as a lowercase e with a negative subscript. It has a -1 charge. Its mass in atomic mass units is 5.486 times 10 to the minus 4 AMU. In terms of the masses that we look at, we want to kind of put these on a relative mass scale. So if we want to approximate here, The proton and neutron are roughly the same mass, so we'll give them a mass of 1. The electron, compared to these, is much, much smaller. So we're going to approximate that mass is going to be 0 compared to the proton and neutron. Because when we're dealing with elements, we would need thousands and thousands of electrons to even come up with the relative mass of 1 proton or 1 neutron. Our element count doesn't go that high, so we can just assume that the relative mass of the proton and neutron is going to be 1, and the electron